Let us look at another example of time value of money. An investment promises to pay rupees 2000 at the end of each year for the next 3 years and rupees 1000 at the end of each year for years 4 through 7. Part A of the question is, what maximum amount will you pay for such investment if your required rate is 13%? And B, if the payments are received at the beginning of each year, what maximum amount will you pay for the investment? So let us first draw this example on a time scale. So the total tenure is 7 years. So 0, 1, 2, 3, 4, 5, 6, and 7. Now this investment is going to pay off rupees 2000 at the end of each year for the next 3 years. So the first 3 years we are going to get rupees 2000 at the end of each year. And then rupees 1000 for years 4 through 7. So 1000, 1000, 1000, and 1000. Now the question A is, what maximum amount will you pay for such investment if your required rate is 13%? So if you were to make an investment today, how much will that amount be so that you get this stream of cash flows at 13% per annum? So what is the present value? So this present value will be the present value of each of these individual cash flows and so on. Now let's say this first one is PV1. So this PV1 at 13% will become 2000 rupees at the end of first year. PV2 will become 2000 rupees at the end of second year at 13% per annum, and so on. So basically PV, that is the total amount, is equal to PV1 plus PV2 plus PV3 plus PV4 plus PV5 plus PV6 plus PV7. Now each of these present values has to be found out in order to find out this total present value. Now, as we have seen in the video for the fundamentals of present value of an uneven cash flow, there are multiple methods by which we can solve this problem. In this example, we'll use the method of present value factor of a lump sum. Now, why did I refer to the present value of an uneven cash flow? So as you can see here, this series of cash flows is uneven. For the first 3 years, we are getting 2000 rupees, and for the next 4 years, we are getting 1000 rupees. Now, since this is not an annuity, each individual payment at the end of each year can be considered as a lump sum payment, and so we can use the present value factor of a lump sum. So basically we'll have PV1 is equal to future value 1 into present value factor, where n is equal to 1 and I is equal to 13, plus FV2 into present value factor, where n is equal to 2 and I is equal to 13, plus FV7 into present value factor, where n is equal to 7 and I is equal to 13. Now let's look at the table for present value factors. So this is the table representing present value factor of a lump sum. Now in our case we have periods 1 through 7 and the rate of interest is 13%. So basically the present value factor values are these. So let us use these values in our formula. So FV1 in this case is 2000 and present value factor of a lump sum where the tenure is 1 year and the value of interest is 13% comes out to 0.8850. For PV2 again the FV2 value is 2000 and the present value factor for N is 2 and I is 13 comes out to 0.7831. So let me note down the remaining. So these are the values. Now let's calculate. So 2000 into 0.8850 plus 2000 into 0.7831 plus 2000 into 0.6931 plus 1000 into 0.6133 plus 1000 into 0.5428 plus 1000 into 0.4803 plus 1000 into 0.4251. So the answer is 6783.9 rupees. So basically an amount of 6783.9 rupees when invested today at 13% interest per annum will allow us to withdraw this series of cash flow. Now let us move to part B. So now part B says that if the payments are received at the beginning of each year, what maximum amount will you pay for the investment? So at the beginning of first year, we are receiving 2000 rupees. At the beginning of second year, we are receiving 2000. Beginning of third year, again 2000. At the beginning of fourth, we are receiving 1000. Beginning of fifth, we are receiving 1000. Again 1000 and again 1000. So we have to find out the present value so that this present value when invested at 13% interest per annum will allow us to withdraw this series of cash flow. Now again, as we saw in part A, we have to find out the present value of each of these individual cash flows. So this 2000 initial payment will remain as is. The 2000 at the beginning of the second year will give us PV2 when discounted at 13%. This first one can consider PV1. Similarly, this one will become PV3 and so on. So again the same thing, PV is equal to PV1 plus PV2 plus PV3 plus PV4 plus PV5 plus PV6 plus PV7. Now the first present value is 2000. PV2 is the 2000 rupee payment received at the beginning of the second year. So this will become FV2 into present value factor where N is 1 because this is going to be discounted for 1 year, or in other words PV2 when invested at the beginning of the tenure is getting interest of 13% only for 1 year, and I is equal to 13 plus for PV3 it will be future value 3 into PVF N is equal to 2 and I is equal to 13 and so on And for PV7, that is this one here, this will be FV7 into PVF n is equal to 6, because this amount here is going to get 13% interest for 1, 2, 3, 4, 5 and 6 years, and I is equal to 13. So let us look at the present value factor table for a lump sum to get these values. Note that the last value of present value factor has n is 6 and I is 13. So this is the table for present value factor of a lump sum. Now the number of periods in our case is 6 and the rate of interest is 13%. So the present value factors for us are all of these. So let us use these values in our formula. So this is 2000 plus FV2 is 2000 into present value factor value for n is 1 and I is 13 is 0.8850 plus, so let me note down the remaining values. So these are all the values. Now let's calculate the overall present value. So 2000 plus 2000 into 0.8850 plus 2000 into 0.7831 plus 1000 into 0.6931 plus 1000 into 0.6133 plus 1000 into 0.5428 plus 1000 into 0.4803. So the answer is present value is equal to 7665.7 rupees. So basically this much amount when invested today at 13% interest per annum can give us this kind of a cash flow.